Okay, then how does spark ignition engine run? That is the next question. Okay, uh, there are two types of SI engines. The first type is four-stroke SI engine, and another one is two-stroke SI engine. Okay? I hope you remember, how the stroke is defined as in the SI engine. So stroke means the motion, the movement of piston. Okay, either from bottom from BDC to TDC, or from TDC to BDC. That is what we call as stroke. So four-stroke spark ignition engine is an engine that makes four strokes or four movement either up or down as one cycle. Okay? So the piston moves up and down. So usually two strokes makes one rotation. Okay? So four strokes means that you have up, down of your piston. So what it means is that four-stroke SI engine should have two rotations of your crankshaft as one cycle. Compared to that, two-stroke SI engine has two strokes or one rotation as one cycle. Okay. I'm going to briefly discuss this type of two-stroke spark ignition engine in short minutes, but I'm going to focus more on, in terms of spark ignition engine, is four-stroke SI engine. Okay. Then please pause this lecture video again and enjoy another video clip that I have uploaded to Canvas. Okay. So that shows how that four-stroke SI engine works. Okay, that is quite fun. So please enjoy this video and come back to this video, my lecture video. Pause. Okay, now, have you enjoyed this video? Have you seen how piston moves up and down, and how intake valves and exhaust valves close and open, and where this combustion process should be happening, and when does this combustion process or ignition of spark occur during this entire four-stroke processes? Then let us discuss one by one. So I'm going to talk about one stroke, second, and third, and fourth stroke. So these are very simple diagram of how your four-stroke SI engine makes up the four strokes as a process of that cycle. So the first stroke is intake stroke. Okay. And second stroke is compression. Third is power or expansion stroke. And the last stroke that makes your four-stroke engine operation is the exhaust stroke. Okay. Then what happens in the intake stroke? So during the intake stroke, your piston initially is positioned at the top at TDC, moves down to BDC. During this moving down stroke, your intake valve is opened. Okay? And during this intake stroke, very fresh air and fuel mixture can come into your cylinder. Okay? So it's basically air and fuel mixture is kind of sucked into the cylinder while the piston moves to the bottom. Okay? Then the next stroke is the compression stroke. After intake stroke, then intake valve is closed, and still the exhaust valve is closed. So now all valves are closed and there is no way that air and fuel mixture can get out. In that situation, now piston moves up to the TDC. So what you can imagine would happen during this stroke is your air and fuel mixture is compressed. Its pressure goes up, and at the same time, because of the ideal gas law, the temperature also should go up. And right after compression, in reality, almost at the later part of compression stroke, then your spark plug makes a kind of spark, okay, in that cylinder. Now, combustion happens instantaneously as soon as there's a spark plug, ignite, kind of spark, is generated, in a spark plug. Okay. Then now you have like high pressure, air and fuel mixture that is already at quite high temperature, and they are kind of ready to burn, but they are not high enough. They don't have high enough pressure and high enough temperature to ignite themselves. But at that moment, the spark plug helps them. Like, okay, now let's ignite. Then what happens is that in a very short time frame, your air and fuel mixture drastically has a chemical kind of reaction combustion process that totally burn up everything. It happens so quick. Okay, then this after combustion, burn gas has drastically higher temperature and drastically higher pressure. So this piston, which is at the top position, is pushed strongly back because of this high pressured burn gas. So then piston should push back to the bottom side, and that is an expansion process. Then the next stroke is piston again goes back up to the TDC, and during this time, exhaust valve is opened such that those burn gases can go out. Okay. So this is a brief description of what really happens during this four-stroke processes of that type of SI engine. Now, please, then we can imagine, obviously, because we are learning those kind of processes in thermodynamics, what we really care is the measurable variables, measurable properties. As I said, we have three key measurable properties. One is pressure, second one is temperature, and third one is volume. Okay, so those three are measurable. And let's assume that we measure pressure and volume, okay, during these four-stroke processes. And yes, we can measure them. So now let's try to draw a PV diagram based on this measurement. Okay? Then now let's go to the intake stroke. Okay? So during this intake stroke, what does really happen in terms of pressure is the pressure should be lower than the atmospheric pressure. That's why the air and fuel mixture can be sucked into the cylinder. But this is not very lower than the atmospheric pressure, is slightly lower than the atmospheric pressure. Then what happens to the volume? So again, because piston goes down from TDC to BDC, what actually happens basically in terms of volume is that volume increases from the minimum volume or clearance volume to the maximum volume, okay, the BDC volume. So as you see in this PV diagram, we have slightly lower pressure while it does have volume change from TDC to BDC. So that is what happens in terms of PV diagram during the intake stroke. Then during the compression stroke, we have compression. So now piston goes back from the bottom to the top. So again, during this compression process, we should go follow that curve. Okay. As you clearly see that, during the compression process, the air and fuel mixture is compressed to increase its pressure. Then at the end of this compression stroke, there is an ignition because of spark plug. And as I said, they are so ready because they already have high temperature and high pressure. And as from the help of spark plug, this combustion process happens so quick. So almost at the same volume. So this compression process happens almost at the same volume here. Okay. Then it does have really high pressure. It does have also very high temperature. And it's so strong such that it pushes the piston back to the bottom during the expansion. And obviously during the expansion, we also should have certain pressure decrease. And that's why we have that kind of curve here. Okay. And right before this piston goes to the BDC, then your exhaust valve is designed to open a little early. Then now imagine what would be the pressure at the time the exhaust valve is open. At least you know that this pressure inside the cylinder should be much higher than the pressure of the atmosphere. So as soon as you open the exhaust gas, because of high pressure difference, there must be kind of instantaneous blowout of burned gas. Okay, so now we have very quick jump down of pressure because of this open exhaust valve, and we call that as exhaust blow down. Okay, but still there are certain burn gas remained in the cylinder. Then the exhaust stroke starts. So during this exhaust stroke, your piston again moves back up to scavenge all remained burned gas out of the cylinder. Still exhaust valve is open. So, and because it's kind of push process, the pressure inside the cylinder should be slightly higher than the atmospheric pressure. So that is how we can draw this process of exhaust process this way. And now again, intake valve opens. Then we go back to intake stroke and make certain cycles.